Before we do that, we're just going to have a short introduction to the practical physics of basically explaining why a moving motorbike actually wants to stay upright. Now, I don't know if you've ever balanced a hammer on the palm of your hand. I won't ask why, but essentially what you're doing is trying to keep the contact patch of the hammer beneath the center of gravity. And when you keep the contact patch underneath, it balances. But if the center of gravity moves to one side, then to restore balance, you have to move the contact patch back underneath the center of gravity. So if it falls to the left, you move the contact patch to the left to get it back underneath. And it's the same principle with trying to keep a motorbike upright, because what you've got with the bike, you've got your two contact patches where the tyre is in contact with the road, and if the bike falls to the left, you will steer left to bring the contact patches back underneath the centre of gravity, and if it falls to the right, you will turn the handlebars to the right to again steer the contact patch underneath the center of gravity. And when that contact patch is underneath the center of gravity, it's all in balance and the bike will stay upright. And that is something called active balance. This moving the contact patches around underneath the center of gravity is called active balance. But there's also another kind of balance, inherent balance. The actual bike is designed to inherently balance and stay upright. And this is really something to do with something called trail and steering geometry. Now, very simply, what you have is the trail is to do with the angle of the forks and how it relates to a point perpendicular to the ground. And what would happen if I got Ben, I won't ask him to do it because it's a lovely bike, but if I got him to straddle this bike and take it off the stand and just sort of lean it to one side, take his hands off the handlebars, so he leans it to the left, which way would you expect the front wheel to go? So if he leant it left, no hands, which way would you expect the front wheel to fall? To the left. And if he leant it to the right, you'd expect it to fall to the right. And what's that going to do? If you are moving, the steering is automatically moving to bring the contact patch back underneath the center of gravity. And again, that's to do with the trail. And what you'll find is that different bikes have different steering geometry and therefore have different trail. And so a sports bike has a much steeper fork angle, and so what that means is that it's less stable, but it turns quicker. A cruiser has a much shallower fork angle, so it's more stable, but of course, you know, turns a lot slower. So every bike is different, but actually inherently the bike wants to stay upright. I don't know if you've ever seen MotoGP, where somebody kind of gets unceremoniously ejected from the bike, and the bike itself sort of does a little jink, and then it just carries on, doesn't it? Straight as an arrow until normally it hits something and stops. But what's happened there is that the actual design of the bike, the geometry, has made it get the contact patch back underneath that center of gravity. And so, you know, it's not difficult for a bike to stay upright. There are, of course, some other forces at work as well. There's the gyroscopic forces of the wheels. So, you know, if I spin a wheel and get it going a little bit faster than that, what you find is that in an up and down motion, it's very stable, and you know, it stays like that. But if I try and move it left and right, it's quite resistant to that. And obviously, as it kind of slows down, it gets less and less stable. So the effect of the gyroscopic forces of the wheels is most effective when the bike is going faster, but it is there. It actually helps the bike stay upright. So again, you know, it's not the most important thing. Steering geometry is actually the most important factor here in the inherent balance. But what it demonstrates really is that a bike wants to stay upright, and if we're moving that bike and we keep the inputs all very consistent, the bike will stay upright and move in you know, a very nice, smooth, upright direction.